After studying linear equations, a natural next step is to solve linear inequations, or what is typically called linear inequalities. So that's what we'll look at in this screencast here. So let's get introduced to the topic by looking first at this scenario. Speed limit signs, you see them all the time. Did you know that inequalities are associated with them? So this particular speed limit sign says the speed limit is 55. What does that mean for drivers? Well, in words, simply, you are not permitted to drive over 55 miles per hour. So what speeds could you go? For example, you could go 54, you could go 52 miles per hour. Are you allowed to go 55 itself? Yes, you're allowed to go 55, you're just not allowed to go over it. So let X represent any legal speed. We want to write a comparison between X and 55. How do they relate to each other? So we've got X and we've got 55. How do they relate to each other? Is it this? If X is any legal speed, does it mean that X has to be 55? Is that the only legal speed? No, 55 is a legal speed, but it's not the only one. So what's the general relationship between X and 55? So you're allowed to go 55 miles per hour or less. Said differently, any legal speed X has to be less than or equal to 55 miles per hour. And the way we write that, as many of you already know, is X is less than or equal to 55 miles per hour. This is one of 4 possible linear inequality symbols. Let's look at all of them. Up here on the right, we have our basic inequalities. This was read as X is less than A. And these are our basic inequalities. This one would be read X is greater than A. This one here is X is less than or equal to, when that additional line is there, A. So X is less than or equal to A. And then finally, this one is X is greater than or equal to A. So X is greater than or equal to A. These are the 4 basic inequalities. Now, technically, all 4 of these can be written in a different way. So let's take this example and see if we can figure out how to rewrite this. Can X is less than 7, again, that's read as X is less than 7. Let's just write that down. X is less than 7. Can that be written equivalently with the greater than sign? So is it possible to write something is greater than something that's equivalent? So we have X is less than 7. Can we write that equivalently using the words greater than instead of less than, is essentially what this is saying. And if you think about that, you can. We can't simply just write X is greater than 7 again, because you can't say X is less than 7 and then say X is greater than 7. Those 2 statements are contradictory. So what should we write instead? Well, if you're not quite sure, let's first take a quick look at this. Let's use regular words, take it away from mathematics for a moment, and then we'll come back to this. So Shaquille O'Neal, when I write Shaq here, that's who I'm referencing. Shaq is taller than me, Professor points out. So could I say that differently, but use my name first before Shaq? So this is a true statement. Shaquille O'Neal is taller than Professor Poinsett. Shaquille O'Neal's about 7'1". I'm 6 feet tall. So is there another way of saying that with me first? And that would be precisely Professor Poinsett is shorter than Shaq. Those 2 statements are equivalent. So the equivalent of X is less than 7 would be the flip of these things with the greater than. So it would be 7 is greater than X. These 2 statements are exactly the same. So technically, every single one of these could be written equivalently in the following way. X is less than A is the same thing as saying A is greater than X. Or X is greater than A is the same thing as saying A is less than X. X is less than or equal to A is the same thing as saying A is greater than or equal to X. And X is greater than or equal to A is the same thing as saying A is less than or equal to X. So if you were to flip the two sides around, you simply don't keep the symbol. You actually have the entire symbol flipped over. So the greater than or equal, for example, becomes less than or equal, and the less than sign becomes greater than sign. With that in mind, which two of the following linear inequalities are equivalent? 4 is less than or equal to x is less than or equal to 4, or x is greater than or equal to 4. Two of those are equivalent. What's the answer? Well, 4 is less than or equal to x. If I want to rewrite that with the x on the left-hand side, I would also need to flip this sign. So from less than or equal to, it would have to switch to greater than or equal to. So these two are the same. 4 is less than or equal to x is the same thing as x is greater than or equal to 4. These are the four basic inequalities. We also have compound inequalities. We'll look at those on the next slide. You may have been thinking when we initially did the speed limit scenario that technically x can't be less than 55 for any number x. For example, -7 is less than 55, but you can't travel at a speed of -7 miles per hour. So let's take a look at that scenario again. You don't see this too commonly in New Jersey, but other states and certainly other countries often have speed limit signs that look like this. Not only would it say speed limit of 55, that means that's the max speed that you can go, but they also give you the minimum speed. Because technically, think about it. If someone's going a legal speed of 55 miles per hour and another person is going less than that, say 5 miles per hour, that would be extremely dangerous because the 55-mile-per-hour person is going so much faster than the 5-mile-per-hour person that the closing distance between them would be extremely quick. It would be very short. So you technically have for every road not only a speed maximum, but you also have a speed minimum. They're just not always posted. So let's revisit this problem now with the reality that technically the speed max is 55, but there's also a minimum of 30. For example, anything below 30 miles per hour is too slow compared to somebody that may be going 55 miles per hour. So let's let x represent any legal speed. How does x relate to 30 and 55? And now we're going to create the compound inequalities from this scenario. So the way that I would write this is x, a legal speed is literally between 30 and 55. So I'll write 30 here, 55 here, and put the x in the middle. In general, whenever we write compound inequalities, we always have the larger number to the right. So you would put the 55 here as opposed to over here. It is possible to technically write it the other way, but people rarely do that sort of thing. So in general, make sure your B is larger than A. If you look down here, I have the B's are on the right and the A's are on the left. So make sure this number is larger than this number. Now, we know that x is between 30 and 55, but how do we write that it's between using mathematical inequality language? Well, first, let's break this out and look at these individually. How does x compare to 55? Well, we saw that on the previous screen, that x is less than or equal to 55. So it should make sense that that should be right here. X is less than or equal to 55. But then how does x compare to 30? Well, x can be anything greater than or equal to 30. So we want x to be greater than or equal to 30. However, if you look up here, this has got the 30 on the left of x. So how do I rewrite this so that the 30 is on the left? Well, that's what we just saw on the previous screen. You can flip this around as 30 is less than or equal to x. Now this is in the same order as it is up here. So this symbol would go right here. The way this should be read is that x is between 30 and 55 inclusive. The word inclusive means specifically that you're including both of the endpoints. You're including the 30 and you're also including the 55. We'll write that language down when we go over this. So there's four possible compound inequalities. Sometimes you may hear these called double bounded inequalities because they're bound on both sides. So you've got this, and this. We want to say how you would write each of these and what does it mean. So in this case, x is between a and b, but notice you don't have the line underneath either of these. So that means that x can't actually be the endpoint a or the endpoint b. So the way we would write that is x is between a and b, exclusive. If you use the word exclusive, that means it ignores both of the endpoints. X can't be A and X cannot be B. In a scenario like this, we would say that x is still between a and b, but in this case, x can be b because x is less than or equal to b. So x can be b, but it can't be a. So I would write here x is between a and b, including b, but not a. The way that this one should be read is x is again between a and b, but this time it's including a, but not b, because the equality part is over here with respect to a. So x is between a and b, including a, but not b. And then the final possible scenario with compound inequalities is x is between a and b, and x can be both a and b. And the way we write that is this: x is between a and b, and now we use the word inclusive. Inclusive means we're including both the endpoints a and b. These are the four possible compound inequalities. You don't have it where you have greater than signs, because remember, in general, these are always written with the b being the larger number. So the larger number goes to the right as opposed to the a values on the left. As long as you do that, you would never have the inequality symbols flipped the other way. These are the four possible ones.